Hello guys, this is a video solution for the problem sheet for weeks 6 and 7. There are 13 questions. I will go through each of them and give you a detailed solution. Right? Please note that this video solution is on top of the typed solutions and the handwritten solutions, both of which you can find on the course website. So the first question is having the CDF equal to 1 minus e minus lambda x, and this, as you can recognize, is the CDF of the exponential distribution. So the first thing we need to do is to find the formula for var. So to do that, you set the CDF equal to p and solve for x in terms of p. Alright, this implies that x alright, hence the formula for var, or value at risk, is given by this. Alright, next, to find the formula for the expected shortfall, we use this formula which I gave before. So using this, you can write this, subbing this into this, you can write this as minus Now, integration of this is not difficult. I mean, you can do it in different ways. One way to do this integration is by parts, right? So I hope you remember integration by parts. So if you do that, you get t alright, then you have minus integral from 0 to p of t multiplied by the derivative of this term, which is alright. Just to remind you, at this step I have used integration by parts. Okay. Right. Now taking the limits at 0 and p, this is what you get. You get minus 1 over lambda p. The limit at p is p times log of 1 minus p. The limit at 0 is 0. Now, I'm going to write this as follows. You see why I'm doing this in a minute. Okay, I'm going to put the first two terms in brackets. So this becomes right. Now, if you divide 1 minus t by 1 minus t, you get 1. If you divide 1 by 1 minus t, you get this. okay, dt. Now, as you can see, the integration of each of these terms is straightforward. So the integral of 1 is t, the integral of 1 divided by this is plus log of 1 minus t. Right, then you take the limits from 0 to p. Alright, so the answer is, the final answer is as follows. At p, the limit is this, and at 0 it is 0. So this is the expression for the expected shortfall for the exponential distribution, right? Okay, now we'll go to part 2. Okay. So this is part 2 of sheet 6. So here you're given the CDF fx equal to x power a, x between 0 and 1. So to find the var, you set the CDF equal to p and solve for x. So this implies that x power a is equal to p, which implies that x is equal to this. Hence, the formula for var is this. Okay, now to find the formula for expected shortfall, you use this, right? So this is 1 over p times the integral 0 to p of t power 1 over a dt. And this integral is easy. You get t okay. Taking the limits and simplifying, this is what you will get. You get alright, so that's the expression for ES for part 2 of sheet 6. Now part 3. Is the uniform distribution on the interval from A to B. So the CDF, I'm sure you know from year 1 that the CDF of a uniform A to B is x minus A divided by B minus A for x between A and B. Okay. So in order to find the var, you set this. So you get x minus A divided by B minus A equals to P. So x is equal to so this implies that var is equal to this. Now to find the expected shortfall, you use the familiar formula, which is this. Integration is easy, so you get 1 over p times at plus t squared by 2 times b minus a. Take the limits from 0 to p, and you simplify this, you will get a plus p by 2 times b minus a. So this is the expression for expected shortfall for part 3. Okay, now part 4. You have the CDF fx equal to 1 minus k divided by x power a, where x is greater than k. This is known as the Pareto distribution, right? So to find the var, you set the CDF equal to p, which implies that is equal to p, and this implies that k okay, so this implies that x is equal to k times 1 minus p power minus 1 over a. Okay, so your formula for var is equal to k times 1 minus p. Alright, the next thing is to find the expected shortfall using this formula. Alright, so this becomes k divided by p times the integral of 1 minus t. Okay, and the integral of this is not difficult, so let's see what happens. So this is, if you integrate this, you get 1 minus t to the power 1 minus 1 over a divided by 1 minus 1 over a times minus 1. Then you take the limits from 0 to p. Okay. Now let's pull this outside, so this becomes k divided by p. Okay, and the limit at p is 1 minus p, and the limit at 0 is 1. Okay, so this is the expression for expected shortfall for the Pareto distribution, right? All right, the next one is part 5. Part 5 is the standard normal distribution. So the CDF f of x is equal to phi of x, which is the CDF of the standard normal distribution. So in order to find var, you set fx equal to p, same as phi x equal to p, and this is the same as x equal to phi inverse at p. Hence the formula for var is this. Okay. All right, now to find ES, we use this. So this you can write as 1 over p times integral from 0 to p of this. Alright. Well, this cannot be simplified further, so you have to leave it like this. Okay. So that's part 5 of sheet 6. Now part 6 is the following. So here the CDF is given as fx equal to as this, right? And this distribution is known as the logistic or log logistic distribution, right? So to find the var, you set the CDF equal to p. All right. Okay, so this becomes one over p minus 1. Okay. So this is saying that x divided by a is okay. So x is equal to a times okay. So hence your formula for var is this. Now in order to find ES, we use this formula. Okay, so this, if you sub this here, you will get a divided by p times the integral from 0 to p of t okay. Now this kind of integral is a well-known integral in mathematics, right? And let me tell you what the name for this kind of integral is. So if you have b, it should be bx. B. If you have two numbers, say alpha and beta, right? B sub x in brackets alpha comma beta is defined as this. All right, and this integral is known as the incomplete beta function, because remember in the definition of beta function the integral is from 0 to 1. Now here the upper limit is not 1 but it's x, right? X is a number between 0 and 1, right? So that's why you have this term incomplete, because it's not the same as beta function but with a different limit, which is any number between 0 and 1. Okay, so this is a well-known function, a special function in mathematics, right? Okay, so using this definition, we can write the above as follows. So your alpha is going to be 1 over b plus 1, and your beta is going to be 1 minus 1 over b. All right, so that completes question 6. All right. Okay, next one, question 7. So here the CDF is given as the following. X is greater than 0. So in order to find the var, you set the CDF equal to P, which implies this is equal to P, right? And this implies that okay, and this implies that alright, so hence your X is equal to lambda times okay, so your expression for value at risk or var okay. Now the expression for expected shortfall is as follows. Okay, so you just sub this in here, so you get lambda by P times the integral from 0 to P of okay, and this integral is not difficult. See, so the integral will be 1 minus t power 1 minus alpha divided by 1 minus 1 over alpha times minus 1, and the integral of 1 is simply t, right? Then you take the limits from 0 to p, right? So the limit at p is this, and the limit of this at 0 is 1. Okay, so this will be this, right? And the limit of t at p is p, and at 0 is 0, so it's going to be minus p. So this is the expression for expected shortfall for part 7 of sheet 6. Right. Okay, next is part 8. So here you are given the CDF, following CDF, fx is equal to e power sigma divided by x power alpha. All right, and this is known as the Pareto distribution, right? Okay. Now, in order to find the var, you set the CDF equal to p, Alright, so, and if you solve this, you get okay, and so you get sigma over x is equal to minus log p power 1 over alpha. So your x is equal to sigma this. Okay, so your hence the expression for var okay. Now in order to find ES, we use this formula. Right, so which is the same as, okay, if you sub this here, you get sigma by p, the integral from 0 to p of minus log t minus dt, right? Now to do this integration, a substitution is needed. I mean, you can do it in other ways too, but one way is to make the following substitution: y equal to minus log of t, which implies that t is equal to e minus y. So dt by dy is minus of e minus y. Right, so let me put this in a box. Okay. Now if you sub this back into the integrand, this is what you will get. Okay, first of all, the limits of integration. When t is 0, this is minus infinity, minus minus is plus infinity, right? And when t is p, you get minus log of p. And then you get y power minus 1 over alpha, and then you have minus of e of minus y dy. Right? Now I'm going to use this negative sign to change the limits around. So this becomes this. All right. Now, if you look at this integral, this is very similar to the gamma function. The only difference is that the lower limit is not 0. The upper limit is infinity, but the lower limit is not 0. So this kind of function, or this kind of integral, is known by a special name in mathematics. I will write it down in a sec, okay? When you have an integral, say, from x to infinity, right, of, say, t power a minus 1 e minus t dt, right, this integral is denoted by this notation, right, and is known as the lower incomplete gamma function. The reason for this name is just what I explained, that this is different from the gamma function in the sense that the lower limit is not 0. It's a fixed number instead of being 0. So that's why you get this name, lower incomplete gamma function. All right? So I'll put this in another box. All right. All right. So using this definition, you can write this guy here as follows. Capital gamma, your A is going to be 1 minus 1 over alpha, and your X is going to be minus log of P. Alright, so this completes question 8. Let's move on to the next one, which is question 9. Right, you can see it, yes. So here the CDF is given by the following. Right, and this distribution is known as the Weibull distribution. All right, so now to find the var, you set the CDF equal to P, which implies that is equal to P, and this implies that minus P. So X divided by sigma power alpha is minus of log of 1 minus P. So your X is going to be sigma okay. So your var, the expression for var or value at risk is equal to sigma times this. Alright, now in order to find expected shortfall, we use this formula. Alright, subbing this into this, you get sigma by P of this. Right, to do this integration, once again I'm going to make a substitution. So this time I will substitute for minus log of 1 minus t. All right, so that means your 1 minus t is equal to this, right, and your t is equal to 1 minus this, and your dt by dy is equal to this. All right, let me put this in a box. Okay, now subbing here this into this, you will get the following. All right, firstly the limit. When t equal to 0, this guy here will become 0. When t is equal to p, the upper limit is this, right? Okay, guys. So this will become y to the power 1 over alpha multiplied by e minus y dy. All right. Now this integrand is again similar to the gamma function, except you don't have infinity as the upper limit. Instead of infinity, you have a fixed number. The lower limit is 0, but the upper limit is not infinity. So there is a name for this kind of integrand, which I will write down now. It's denoted by little gamma, not capital gamma. This is the notation, and is defined by defined by this. And this integral is known as the upper. You can guess why upper is used. All right, so let me put this in a box. All right, so you see the term upper incomplete refers to the upper limit being a fixed number instead of infinity, right? Okay, so using this definition, we can write this as follows. Your A is 1 plus 1 over alpha, right? And your X is this. All right, so this is the expression for expected shortfall for part 9. Okay. Next, part 10. Okay, here you are given the CDF fx equal to the following: 1 minus cx divided by k power 1 divided by c, where x is positive. Now this is the generalized Pareto distribution which we talked about much earlier on in this course, right? So to find the var, you set the CDF equal to P, which implies okay, so this implies that this implies that okay, so this implies that C x divided by k is equal to this. So x is equal to k by c. Okay, so this is the expression for var. All right, now in order to find the expected shortfall, we use the familiar formula. Var t x dt. Okay. So this becomes, if you sub this here, you get k divided by c times p, then the integral from 0 to p of 1 minus t power c dt, right? And the integral of this is not difficult, so you get k by c over p t, and the integral of this is 1 minus t power c plus 1 times minus 1. Okay, you take the limits from 0 to p, so this is going to be the limit at p, limit at 0 gives you p, and minus the limit at p is the minus minus is actually plus, sorry. The minus, these two minuses gives you plus. So the limit at p is 1 minus p power c plus 1, and the limit at 0 is 1, so divided by c plus 1. So this is the expression for expected shortfall for part 10. Okay. All right, the next part is 11. All right, in this case, what the question gives you is the quantile function. A quantile function, I might have mentioned this before, a quantile function, this is the definition of a quantile function. And this is given as all right, so basically the question gives you remember the quantile function is the same, is the definition of var also, because remember var, you may recall, is defined as the quantile function. In other words, inverse CDF at P. So the question has already given you the formula for var. So what you need to find is the expected shortfall, right? So you will use this formula. All right, so subbing this over here, you get 1 over p lambda integral all right, the integral is not difficult, so you get t lambda plus 1 divided by lambda plus 1 minus 1 minus t lambda plus 1 divided by lambda plus 1 times minus 1, right? Right, taking the limits, you get at p is p power lambda plus 1, at 0 is 0, so this is what you get. Okay, minus minus is plus, so at p you get this, at 0 is 1, so this is the answer for expected shortfall for part 11, right? Next one is part 12, right? Okay, here once again you are given the quantile function of a distribution, and it's given as p power beta minus 1 minus p power gamma divided by delta, right? Okay, so once again, you may recall that the definition of var is also the quantile function is basically the same as var, so it's equal to what is given in the question. All right, so all you need to find is the expression for expected shortfall. Right, which becomes 1 over p delta times the integral of t power beta 1 minus t power gamma. All right, so integrating this, you get the integral of this is All right. Taking the limits, this is what you will get. Minus minus is plus, so it's 1 minus p power gamma plus 1 minus 1 divided by gamma plus 1. Alright, so this is the expression for expected shortfall for part 12. Right, and finally we arrived at part 13, which is the last part of sheet 6. So here you're given the quantile function c p to the power alpha divided by 1 minus p power beta. Right, so once again the expression for var is the same as the quantile function by definition, and the same as what is given to us in the question. Alright, so all we need to find is the expected shortfall. Okay, so this becomes right. Now you may recall this integral from earlier on this video. I told you that this kind of integral is known as the incomplete beta function. Right? If you don't remember, I can write it down again. I told you that if you have something like this, this is the definition. This is the notation for the incomplete beta function, defined as the integral of from 0 to x of this, right? This is known as the once again the incomplete beta function. All right. I mentioned this earlier on in this video, you may recall. Okay, so using this definition, we can write this as follows. Capital B, P. Your alpha is gonna, your A is gonna be alpha plus 1, and your B is gonna be 1 minus beta. All right, so this completes part 13.